So a complex fraction is just a fancy word for a fraction divided by a fraction. Okay? So remember, a fraction is any number that I can write as a over b. Okay? If it's a number, a and b are integers, but a fractional expression, what we've been dealing with, these are all polynomials. Okay? So if I look at this from a number standpoint, if I divide 1/2 by 3/4, that's what this is. That's a complex fraction. You've got a fraction divided by a fraction. Okay? So how do we handle that? How do we deal with this? How do we evaluate this? This was not the trick question that I planned for you guys. It's 1/2 times what? Times 4/3. Okay? When you divide by a fraction, that's the same as multiplying by its reciprocal. So this is what? 4/6, which is what? 2/3. Okay? So anytime you see fraction divided by fraction, we want to turn that division into a multiplication. So that is our goal in any of these expressions. So it comes in different forms. So if you see things like a fraction divided by a number, that's also a complex fraction because you've got two fraction bars. This is a over b divided by c. So this is 1/2 divided by 3. How would I figure out 1/2 divided by 3 how would I evaluate that? Yeah. So 1/2 times, what's the reciprocal of 3? No, the reciprocal of 3 is 1/3. So dividing by 3 is multiplying by 1/3. So this is just 1/6. Okay. And then what about this one? You could have a number divided by a fraction. Okay. So 1 divided by 2/5. That is going to be 1 times what? Times 5/2, which is just 5/2. And then the one we did here, like we've done before, this is 1/2 times what? Times 9/2, which is 9/4. Okay? Okay, so we're going to do a little bit of this with numbers, but what we're moving into quickly is to do this with expressions. Okay? 8/25 divided by 25/4. First step to doing this, when you see fraction divided by fraction, you turn this into what kind of problem? Multiplication. So this is 8 divided by 25 times what? No, it's right now, it's divided by 25/4. When it turns to multiplication, it's going to be what? 4/25. Okay? So this is what? 32. And what's 25 times 25? 625. Okay. Now, what is different about the next problem? Yeah. Do I have fraction over fraction at this point? Not quite. What do you see in the numerator? Is that one fraction? It's two fractions that are what? Added together. So in order to get fraction divided by fraction, what do I have to do in the top of that, in the numerator here? Guys, this is fraction divided by fraction. You've got one fraction in the numerator, one fraction in the denominator. Yeah, in order to get one fraction in the numerator, what do I have to do here? You got to add those together. Okay, so in order to get one fraction divided by one fraction, I've got to do something in the numerator, which is addition. So I'm going to have to write this as 5/16 plus, what's the common denominator between 4 and 16? 16. So this needs to be multiplied by 4/4. Okay. So I'm going to have 5/16. So this turns into what? 5 plus 4/16 divided by 1/4. So what's 5 plus 4? 9. So this is 9/16 divided by 1/4. Now, do I have one fraction divided by one fraction? This will be where you say yes, okay? So to turn that division into what kind of problem? Multiplication. So this is 9/16 times what? 4 over 1. And then we can do simplification. What is 4 over 16 is what? That is just 1/4. Okay. So this whole answer is 9/4. Okay. So that's doing with numbers, but we're going to quickly move away from numbers. I would venture to say by the time I get to the next problem, okay, we'll start to have variables involved in the equation. So your goal with any of these complex fractions is to get the problem into where you have one fraction divided by one fraction. Then you turn that division into what? Multiplication, okay? Do I have one fraction divided by one fraction here? No. So what do I see in the denominator? How many fractions? That's where the class would say there are 2 fractions in the denominator, okay? So what do I have to do in the denominator? I've got to combine those, okay? So this is 4 over m divided by what? Negative 12 over 25, okay? And then how do I turn that into a multiplication problem? Yeah, so 4 over m times negative 25 over 12. And then to simplify this, what's 12 divided by 4? That's 3. Okay. So this is, the answer is what? Minus 25 over 3m. So the goal in all of the complex fractions is to do whatever you need to do with the numerator and the denominator to get one fraction divided by one fraction, turn that problem into a multiplication problem. Now, let's start to look at things that look a little bit like this, okay? Now, do I have one fraction divided by one fraction? No. So I've got to get, on the top, I have to have one fraction, and on the numerator, in the numerator side, on the denominator, I need one fraction. So what I've got to do work in both the numerator and the denominator. What do I have to do? What have I got to do to get it fraction over fraction? Pardon me? Well, I'm not sure if I'll make you fraction. Well, I got to make, what do I have to do to get the numerator, instead of being 2 different terms? I got to do what it said. I got to subtract 6 from x over 3. I got to find the common denominator. I've got to add or subtract to make that happen. So what this turns in is to x over 3 minus 6. So what's the common denominator between 3 and that's 6 over 1? What's the common denominator? 3? Divided by, and again I'm going to have 10, so plus 4 over x. What's the common denominator in the bottom of this fraction? What is the common denominator, guys? Here. X, okay? So this has to be multiplied by x over x, okay? Now, so what I'm doing, so this is the same problem. This would have been a good problem on last night's homework. This would have been a good problem on last night's homework. But you see I've got both of those in one problem now, okay? So in the top of this fraction, I'm going to get what? X minus 18 over 3 divided by what? Yeah, 10x plus 4 over x, okay? Now, do I have one fraction divided by one fraction? Yes. Yes, Jack. No, when you add fractions, you only add the numerator, okay? You got the common denominator, you only add the numerators or subtract the numerators. So now I've got fraction divided by fraction. So this turns into what? X minus 18 over 3 times what? Yeah, x over 10x plus 4. Okay, so that's a multiplication problem. So this is just x times x minus 18 over 3 times 10x plus 4. Okay. Now, is that fully factored? Is there anything that can be factored? What can be factored out? Well, the only thing that appears to be factored is 10x plus 4 can be factored. What can be factored out of there? A 2. So if I factored a 2 out, I would get x minus 18 over 6, 5x plus 2. Okay. So I'm probably going to take either of those as the right answer because it doesn't, the factoring there doesn't give you any further simplification. Okay. No other terms are in common. Okay. So our goal here, anytime we see a complex fraction, do what we've been doing. If the numerator has addition in it, do that addition with a common denominator. If the denominator has addition or subtraction, do that operation. Do it until you get fraction divided by fraction. Once you're there, then turn that complex fraction into a multiplication problem. Multiplication, that's what we did on day 1. See if there's any factoring or simplification that can happen in that process. So let's look at the next one here. Now, what people, the mistake people tend to run into is just making careless mistakes, or you've got to work with here. Most of your work is going to happen where in this fraction? The numerator, the denominator. The denominator. Okay, so making a mistake there are plenty of places mistakes can be made. Some of these are going to get more complicated. You'll have as much work to do in the numerator as the denominator. So what has to happen in the denominator? What do I have to do to get this simplified? I've got to add those two things together. So I've got 16 over x minus 2. It's real helpful if you make that a much bigger line since you've got this complex fraction. Now I've got to add 4 over x plus 1. I've got to add that to 6 over x. Okay. What is the common denominator? X times x plus 1. So what does the first fraction have to be multiplied by to get the common denominator? This has to be multiplied by x over x. What does the second fraction have to be multiplied by? Yeah, x plus 1 over x plus 1. So now if you check your denominator, this denominator is x times x plus 1. This denominator is x times x plus 1. So when I do this operation, I will have a common denominator. So this turns into 16 over x minus 2. Okay. What happens here when I multiply the numerator? What do I get? Yeah, 4x. So I'm going to have 4x plus, what happens when I multiply 6 times x plus 1? What is that? 6x plus 6. All of that over x plus 1. Okay. Is there anything that can be combined at this point? Yeah, so what's 6x plus 4x? 10x. So this is 16 over x minus 2 over 10x plus 6 over x plus 1. Now, do I have fraction divided by fraction? Answer is yes. So I turn this into a multiplication problem. So this is 16 over x minus 2 times what? Yeah, x plus 1 divided by 10x plus 6. Now, is there any further factoring that can happen? I mean, there's nothing that can be simplified here, here, or here. Can this be factored any further? This is what, 2 times 5x plus 3? So this is 16 over x minus 2 times x plus 1, 2 times 5x plus 3. Is there any simplification there? What can that become? Well, 16 over 2, that's 8, okay? So the final answer here is, it's going to be 8 times x plus 1 divided by x minus 2, 5x plus 3, okay? That's it. No, there's no solving. This is not set equal to anything, okay? It's just an expression. It's just being able to algebraically simplify this, okay? Now, you might argue, what looks simpler? The original problem or what we just came up with? I mean, it's not a matter of, this may look more complicated, but now this is one fraction. It's no longer a complex fraction, okay? What you don't have to do, you don't have to multiply these things out, That's not going to simplify it for you, okay? Once you've got it in all, it's all completely factored. It's all factors that are multiplied. So if I get out any common numbers, then that's as far as I can go. Yes? Yeah, you could write, instead of 8 parentheses x, you could write 8x. That's fine. What I tend to do here, I tend to overuse parentheses around my variables just so that people don't get in the habit of getting a little bit too cancel happy, so that I know that anything with a variable is expressed as a factor. But you could have written that 8x without a parentheses there. Okay, these are going to get more fun as we go along. So this one just looks like a party waiting to happen, okay? So, do I see one fraction divided by one fraction? No. So what's going to happen in the numerator and the denominator here? Yeah, I've got to get it down to one fraction. So I've got to find common denominators. I've got to do a subtraction in the top of the fraction, and I have to do an addition in the bottom here. So before I can combine, you want to make sure everything is completely factored. Okay, what can be factored when you look at that? X squared minus 4 is what? X minus 2x plus 2. So this becomes 3 over x minus 2 minus 6 over x minus 2 x plus 2. All of that is divided by 3 over x plus 2 minus 1 over x minus 2. Okay. What is my common denominator? Yeah, so here you might have two different common denominators. You might have one common denominator in the numerator and one common denominator in the denominator of the fraction. Question? Oh, you're right. It's a plus. Okay. Okay. So in this case, it just so happens that the common denominator, x plus 2x minus 2, will be the same in the numerator and the denominator of this complex fraction. That's going to help us. That will provide a simplification. But we have to just treat this like two separate problems. So what's the common denominator up here? X minus 2x plus 2. So this has to be multiplied by x plus 2 over x plus 2. So that's what I've got to do to get a common denominator right there. What does this one have to be multiplied by? Yeah, so x minus 2 over x minus 2. And what about here? Yeah, x plus 2 over x plus 2. So what this will give me the common denominator, x plus 2, x minus 2, x plus 2, x minus 2, x plus 2, x minus 2, x plus 2, x minus 2. So it just so happened that in this case, it's the same common denominator in both parts of this complex fraction. So now it's just a matter of you not making any algebra arithmetic mistakes, doing what you know needs to be done. This has to be multiplied by 3 and subtracted from 6. This has to be multiplied by 3. That has to be multiplied by 1. So let's do this. What is this first multiplication here? 3 times x plus 2. What is that? 3x what? Plus 6. And then what is this? So, but I'm not going to multiply that. I'm going to keep that denominator as it is. Okay. I don't need to multiply that denominator. Okay. Does everyone see this is what I got from the numerator here? And then what happens when I multiply 3 times x minus 2? 3x what? Minus 6. And then what happens here? Plus x plus 2 over x plus 2, x minus 2. What is 3x plus 6 minus 6? That's 3x. So this is 3x over x minus 2, x plus 2. What is this 3x? What's 3x plus x? 4x. What's minus 6 plus 2? Yeah, minus 4. Now, do I have one fraction divided by one fraction? Yeah, so what do? Change it to what? Multiplication. So this is 3x over x minus 2 x plus 2 times what? Yeah, x plus 2, x minus 2 divided by 4x minus 4. Now, this problem got a whole lot easier right now. What happens? Yeah, so because those denominators were the same, x minus 2 divided by x minus 2 is 1. X plus 2 over x plus 2 is 1. So this is what? 3x over 4x minus 4. You could factor this one step further, which is what? What can be factored out of that 4x minus 4? 4. That's 4 times what? X minus 1. Okay. But it doesn't provide you any further simplification. So I'm usually okay if you get to one of these final things as your answer, you know, because this further factorization doesn't allow you to simplify any further. If it did allow simplification, you got to go there, okay? So I'm just always try to be in the habit, factor as far as you can. So here's one of those. The original problem looks a whole lot more complicated than the final answer, okay? So really, I mean, the complex fractions, there's not much that's new here. This top, you know, if I look at the top of this fraction, that would have been a wonderful problem for last night's homework. The bottom of the fraction, that would have been a good problem for last night's homework. Here we've got 2 problems from last night's homework divided by each other. So you basically got to do double the work, change it into a multiplication. But you can see here, if the common denominator on the top of this fraction and the common denominator on the bottom of this fraction, if they turn out to be the same, what will happen? They're going to cancel, okay? Because if you had anything like, if you had a over b divided by c over b, okay? This turns into a over b times b over c. That's just a over c. Okay? That's what happened here. I had the same common denominator in both numerator and denominator of the complex fraction, which made this problem get a lot more simple as we went along. Question, Jack? Okay. Okay, let's look at another one, and then you guys can start to take a look at this on your own. So what's the strategy? What do I have to do here? Right, I've got to I've got to get it to one fraction divided by one fraction, which means I've got to add in the numerator and I've got to subtract in the denominator, which means I've got to get common denominators, okay? So if I rewrite this, this is 6 over x minus 5 plus 1 over x. So when I look at that problem, what is the common denominator? X times x minus 5. So I usually I spread it out so then I can just go ahead and take care of the common denominator. That's going to need to be multiplied by x over x. What does the next one need to be multiplied by? Yeah, x minus 5 over x minus 5. That takes care of the numerator. Now let's go to the denominator. You've got 3 over x minus 2 over x minus 5. What's the common denominator here? Same thing, x times x minus 5. So this problem is going to simplify because of having the same common denominator on both the top and the bottom of this complex fraction. Now you can always double check yourself before you go any further. Do you have a common denominator? X times x minus 5, x times x minus 5, x times x minus 5, x times x minus 5. So I do have a common denominator. So what do I get when I do this multiplication? What do I get on the numerator up here? What do I get? 6x plus x minus 5 over x minus 5. And what do I get on the bottom of that fraction? What's 3 times x minus 5? It wasn't the trick question that it's turning out to be. What is 3 times x minus 5? Yeah, 3x minus 15 minus what? Minus 2x, all of that divided by x times x minus 5. I mean, at this point, what you can do, I mean, you see that these denominators are the same. I mean, you can cancel the denominators out at this point, okay? Even though I'm trying not to use this word cancel out. What I typically do, I just try to wait until I turn it into a multiplication, just to be sure. What is this 6x plus x minus 5? What's that? 7x minus 5. So this is 7x minus 5 over x minus 5. What is this one down here? Yeah, x minus 15 over x minus 5. I like to always just wait until I get to the point where I definitely have a fraction divided by a fraction. Then I turn it into multiplication. So this is 7x minus 5 over x minus 5 times what? Yeah. Well, x minus 5 divided by, what was it, x minus 15. That simplifies in a hurry because what? Yeah, you look at x over x is 1. X minus 5 over x minus 5 is 1. So this answer is 7x minus 5 over x minus 15. Okay. So these are straightforward, but you just got to take your time. Don't get in a hurry because any one mistake anywhere can affect you negatively as you go toward the end of the answer here. So again, the whole process for this is just when you have a complex fraction, your goal is to simplify the numerator and simplify the denominator. What I tried to do, what you saw me do, is I sort of did it in parallel. Like I would take, what I would do is like I'd take a step in the numerator and same step in the denominator, try to march them together. If it's easy for you to go off and just deal with the numerator separately and the denominator and bring them back together, that's okay. I tend to just like to work them both as we go. Yes, Jack? Well, this is as far as this can go. So this is not, you can't simplify this any further. Okay? There's no further simplification. So I've got one factor is 7x minus 5 over x minus 15. There's nothing else I can do. Okay? So there's no, you can't say, well, 7x divided by x, the x's cancel. You can't do that. You can't do 7x minus x is 6x. There's nothing else you can do here. You've got one factor divided by one factor. So that's as far as we can go with that.